Good morning everyone. In this module I am going to explain about NP complete and NP hard problem. Before discussing about NP complete and NP hard problem, we have to discuss about basic concepts as well as deterministic problem or non-deterministic algorithm. Deterministic and non-deterministic. Basic concepts means whenever we are writing any algorithm for solving any computational problem, it may have some time complexity. Time complexity means the amount of time the algorithm will take extra amount of time the algorithm take to execute a program is called as time complexity. So here if I am writing an algorithm for adding two numbers, then only 5 lines of code is enough. Start, read the input value, perform computation, store the result, then stop. Only 5 lines of code is enough. So if an algorithm execute within 5 unit second, that is called as polynomial time. The time taken for by an algorithm to execute a task is called as polynomial time. Non-deterministic algorithm means an algorithm will take an extra time. For example, if I have for loop, while loop, then it will have some more than one time, n number of times. So that is called as non-deterministic algorithms. Class P means P represents a problem. It consists of a problem that are solvable in polynomial time. Those I already explained. So more specifically, the problems that can be solved in time of order of n power k for some constant k, where n is the size of the input of the problem. That's what I told you, that if I have algorithm for adding two number, only 5 numbers of line it's enough. So the time taken by execution of the algorithm is order of n power k. So this is that it depends on the size of the input. NP means non-deterministic problem, that is non-polynomial complexity or running time. An extra time will be required to execute the task. So NP means non-deterministic polynomial time, whereas it will verify the value, verify its computation, verify its calculation within the polynomial time. So graph theory has some pairs of problem. One is shortest path problem, longest path is NP complete, Euler's torus, Hamiltonian torus. So those things are NP complete. When we evaluate this NP complete problem, we will have, that's what I put a question mark here, only two answer. One, either yes or no. That is a decision making. So here whenever if there is any conditional part, we have to make the decision either yes or no. This is what this part reveals. Then P is a subset of NP. P means it is a polynomial problem. NP means non-deterministic polynomial problem. It takes polynomial time to run the program. Just run the program and get a solution. That is, NP means it will take an extra time. So P means within the polynomial time it will execute. So P belongs to NP. Undesirable problem. A polynomial with an integer coefficient, it does not have integer roots. Hilbert's end problem will be an undesirable problem, which is impossible to check all the possibles of integers. Even a non-deterministic TM means Turing machine that has to have a finite number of states, and it is more on desirability. Tautology means it will give always true value. Tautology means it always give a true value. What are the hardest NP problems are the notation mean L1 is a language and L2 is another language, where L1 is always less than or equal to problem less than or equal to L2. This means the less than the symbol basically means that the time taken to solve L1 is not worse than a polynomial factor which is away from the time taken to solve L2. NP hard means a problem is said to be NP hard if every problem in NP can be polynomial time to reduced to it. That is L dash. L dash means a language which has been chosen from L. So L dash is less than or equal to polynomial where L for every L dash belongs to NP. So NP complete problem means it need to be in NP and need to be in NP half. If both are satisfied, then it is called as an NP complete problem. Reducibility is transitive relation. Transitive means A tends to B, B tends to C means automatically A tends to C. If you know a single problem in NP complete, that helps when we need to prove the problem is NP complete. So assume a problem is NP complete and all NP complete problems are reducible to this up to problem. Now we have different problems. So if we show P is reducible to P per I, P dash, that is P per I or P dash, then by transitivity all the NP problems are reducible to P dash. So if a problem is said to be reducible, then if a problem is said to be reducible, then we can also say that this is NP complete problem. So this is all about deterministic, non-deterministic and NP hard problems.